Page 2 of the standard study guide. Remember, you are adding anything in a different colored pen or pencil than if you didn't include it in your original answer. And then you are also putting a star next to anything that you don't need to add to. And that's my signal to know that you actually did this video. So what is the acceleration of an object that takes 20 seconds to change from 200 to 340? Okay, so the first step is to write out your formula. Now, if you didn't know that formula, you could have looked it up in your acceleration week handout, WEAQ handout that we did in class. So I look at the change in velocity, and the change in velocity is from 200 to 340. So that means it went up 140 over 20 is 7 meters per second per second. Okay, 140 divided by 20, so that's A. Number 2. Derek is the driver of a train moving at 10. He slows it down to 1.5. So he's going to slow down, and he does that over 20 seconds. So again, A equals delta V over delta T. And he's going to go from 10 down to 1.5. So that's a loss of 8.5. And it took 20 seconds. Okay, so that's the difference of, when I divide it, 0.425 meters per second. Remember, to get full credit, you've got to write out the formula, plug in your numbers, and then write the answer. Matt's new puppy was running at 2 and accelerated to a velocity of 5. Excuse me. Excuse me, I'm not going to stop filming. He went from 2 to 5 in 3 seconds. What is his acceleration during that time? Velocity over time. So he went from 2 to 5, that's 3. And he did it in 3 seconds. So that means for every second he's moving, his speed is increasing 1 meter per second. Okay, so the answer is 1 meter per second per second. All right, I am not going to go over the bonus question in this example. We can go over it in class if you're interested in how to do that. Describe an example that shows Newton's second law. Really what you're doing, now this is not the correct answer because all the answers are going to vary on this. What you are doing is you are showing something where you show the relationship between mass, acceleration, and force. So an example that I used was, I said, if you have a grocery cart and it's empty versus a grocery cart that is full, right? If you want to accelerate them at the same rate, you have to use more force to accelerate the full one. And that's because this one has more mass. Okay, so that's just an example. All right, what is the force of gravity at Earth's surface on the following masses? So what you are looking at with this one is you want to know that F equals ma. And you want to know that the force of gravity is caused by an acceleration. If you look at the activity called Free Fall Challenge, then you know the acceleration of gravity on Earth is 10 meters per second per second. So anytime gravity is causing the force, that means it's going to be 10 for acceleration. So I take my mass, which is 75, times 10, and I get 750 newtons. Here I take 454 times 10, oops, I'll write it the same way, and I get 4,540 newtons. Okay? That's all you got to do to figure out acceleration, or excuse me, force of gravity. Number 3, what is the force of gravity on 4.5 kilogram block of gummy worms, or excuse me, gummy bears? F equals ma. So force is mass, which is 4.5, times, it's the force of gravity, so I'm going to use 10 for A, and I get 45 newtons. That's a lot of gummy bears. Now this one is, what is the mass of a jar of pickles that is pulled down by a force of 167 at Earth's surface? So if I draw my triangle, it says, what is the mass? So I cover up the M, and I know that the formula is F over A. So I'm going to take force, which is 167, divided by A. Now it's on Earth, so it's going to be 10. So 167 divided by 10 is 16.7 kilograms. Okay, that is page 2 of the study guide.